All right, welcome back. I think this is going to be a good video. It's going to be long, but I'll break it up. I'll probably do two separate videos, but by the end of this video, you should be able to take this QGIS program that we're going to add to DragonOS. You should be able to make some map data so that you can use it offline. We'll load that into GeoServer, which I've talked about before, and then that map data, we'll probably try and open up Photon Map with it using it uses cesium, so we'll make some modifications there, and then we will use Signal Server GUI, I think, to do just a basic RF propagation plot, do some analysis on one of the examples that we'll load into Signal Server GUI, and then we will put that on top of the map that we are about to build. Yeah, I think that's what we'll do in this one. And then once we get this down, then we should have everything set up for another video where we can have the Kraken SDRs feeding into DF-Aggregator and have map data. So this is a new image, new ISO I'm working on for DragonOS here. It should be done here soon. So some of this stuff won't be all set up in the current build that's out there. And the only thing that we'll have to add, I debated adding this QGIS in by default, but then it's kind of a bigger package, and I wanted to save some space for some other things. So, and you're going to need internet anyways to initially get the map data. So I have the page up here. You can see free open source geographical information system. I'm not going to have a lot of web pages open this time. We're just going to go through and do it. So you see where the project's at. But to get this going, all we need is to well, we should be fine with these two packages here installed from the repo. It'll get you a long-term support version of QGIS, not the latest, but that should be fine. It works well. So we're going to get that installed. You can see it's 560 some megabytes of or megs of information here. So we're going to get that installed. Shouldn't take too long. Once this is finished, we're going to open it up and we're going to install two plugins that I found pretty helpful. So you can either start it from the terminal, or now if you look up under Education, we have the QGIS desktop. You can also see this build of DragonOS is going to have quite a few new things. Not to get too off topic, but Flipper. So anyways, we're going to load the desktop version of this application. You can see we got some news there. All right. So let me think here. So plugins, we're going to go and we are going to install lat long tool, sorry, under other, lat long tools. This is a fairly new version that we pulled in. You can look up lat long tools GitHub, and there's a slightly newer version. Now the other version, or the other plugin that we're going to need, we're going to install from zip. All right, so we're going to go user source SRC anyways, and then we're going to go into this Dragon Spectrum Awareness Manager. I ended up just calling it this, and I'll explain what this is here in a second, but we want this tile plus zip. So we have the two plugins that we need installed. Okay, let's close this out. we'll go to the Tile Plus plugin, select map, whatever kind of map data you want here. I guess we'll just do the Bing Virtual Earth. And so now we have map data. Okay, coming from the internet right now. Now what I want to do is I want to go, this is the lat long tools, super handy here. And I'm going to go to 51.5 comma dash 0.5. And the reason I'm going to this um, location is because it's the default location on one of the signal server GUI plots. So we're just going to keep this simple. All right, so you can see it takes us right to where we need to be. And so keep in mind, you know, the bigger the imagery, the more resolution. Obviously, the bigger the file size. Let's see, we can do a little measurement here. Miles, 2 miles. Oh, let's see. Let's try this. Okay, so get the imagery that you want. Let's see how big this is going to be. Come over to the layer that it added here. Export, save as. We're going to go rendered image, unclick or uncheck VRT. We'll just do YouTube test. And we just want to do the map canvas, the extent of what I see in front of me. And let me see, horizontal, vertical, layer resolution. So I'm still not super familiar with what this is. The higher number you go there, the columns number goes down. I think the less file size. I think I have that right. But anyways, we'll just do 1 and 1. If it takes a long time, I'll cut out some of the video and come back. So create options should be all right. No compression, and WGS 84. This 3857 I think is fine there. And we'll click OK. Not sure why that comes up, but we'll see if it's going to be all right. So now we can see it's going to build it down here, and it gives us the estimated time. So I guess I picked a bigger chunk than what I wanted. So I will be back once this finishes. All right, actually, we're going to do this again. I'm going to stop that because it's going to take a little too long. We'll come in a little further. We'll go right here. We'll export, save as, just like I said a second ago. Map canvas 1 and we'll leave no compression. Go ahead and click OK. All right, we'll let this run, and then I'll be back. All right, I'm back. So the layer exported and saved, and we can see now if I turn off Virtual Earth, I'm just looking at the image that was made, and we can still zoom down quite a bit actually. So kind of curious File size 8 gigs. Wow. Okay. Well, let's see if this works. So now here is the other thing that I've been working on, and by no means is it perfect, but it works. So under Other, I'm going to go to this DSAM, the Dragon Spectrum Awareness Manager. Little graphical interface came up with here, and it's really important that the terminal starts because we need to put in sudo passwords. But so we're going to start up GeoServer, and that should run. Don't close this terminal, but we can minimize it because we entered the sudo password. That's good for a while. Shouldn't ask for it again. And now we need to, let's see, we can pretty much close out of this program, minimize this, open a browser, /GeoServer. Okay. And I need to make note of that. Put that up here, /GeoServer. Yeah, so just remember localhost 8080 GeoServer. Log in with admin, and GeoServer is the default. You can create new workspaces and add stores and layers. I'm just going to make this simple, and I'm going to use one of the existing workspaces, and I'm just going to jump straight to stores, which manages the stores providing data to GeoServer. I'm going to add a new store. We talked about this before. Go to GeoTIFF. I'm going to put it under the Tiger workspace, and we'll just call this YouTube test. And we need to browse for it, so we'll go here, and we go home, Dragon, that 8 gig file. We'll save and publish this. I'm not going to really change any settings here. Just come down, save, and then let's check layer preview. I just want to make sure this, so open layers. Huh. Well, that's interesting. We'll see if it loads up all the way in when we actually go to use this. So, all right, so we have our layer in there, and we know what it's called. So let's open an editor on Photon Map. It's going to come up and gedit, and you're going to go down, and you're going to look for under the area where add a WMS imagery layer. All I'm going to do, because I've got this defaulted in here now, there's the layer name. So let's put comma, Tiger, YouTube test. Should be it. We'll save that. Close it. Let's check it first. Let's see. Let's start Photon Map. I might change the order of these two because Signal Server GUI on 8083 would probably make more sense. I'll see. It'll be clear what starts on what. So If you go to try this after I've made this video, just pay attention to the port numbers that are here. So let's do localhost 8082. Okay. Let's see. Where are we at here? Let's see. So I'm not sure why it's that big long strip like that, but you'll get better at making the maps in QGIS. Okay, so we've got the map stuff into Photon Map. All right, let's start up Signal Server GUI. That's going to be on 8083. So 8083. And I've talked about this in the past. You can see what it is. I did several videos on this and how you can do RF propagation analysis. Extremely powerful tool. So it's using Signal Server behind the scenes, and yeah. So let's look at some of the plots that we have here. Generic dipole plot. Let's see what this one looks like. We're going to regenerate it. Now, if you're wondering how did I get all this data loaded here, if you look under user source, Signal Server GUI, and we take a look at the README, go to the bottom of it. So I'm in initial Signal Server GUI, the top level directory. I ran sudo python 3, just like you see here, and that initiated this default database. And I guess I should point out too, under user source SD, let's see, under user source data. Actually, let's take a look at config.ini. Elevation data is in user source SDF. And there's a couple files that are there already. I've, again, just referred to their videos I did on Signal Server GUI. This is elevation data that covers these example plots. So that's how it does the analysis based off the elevation data there. So, all right. So let's regenerate this plot. And there we go. Let's download the KMZ. Let's jump back over to Photon Map. Go to File Upload, Browse, Download, and let's see where this KMZ falls. Let's see if we can do. Oop. This is a gigantic plot. Okay. So we would need quite a bit more map data, or at least in the correct area here. Let's see. But I think you get the idea of how this works here. You can flip over this since this does have the internet, and we'll fill the rest in. We can see our patch that's laying over top, but fill the rest in. There you go. Okay, so in the next video, I'll get those couple things worked out that I learned from making this video. We'll get the map data covering, hopefully a big enough area when we're using DF-Aggregator. This, like I said, this plot is I don't even know what kind of settings are on that particular plot, but you could definitely set up something to be way more realistic, and you see how it's pulling information from the GeoServer in the background here. We could go back to Natural Earth 2, and then now we're just pulling the map data from the GeoServer. Completely offline. All right, I think that's it. If there's any questions to ask in the remarks section, and I'll try and get back to you. If I miss something, to make note of it there, and then I will um, cover it in the next video. All right, thanks.